Beneath the frozen waters of the Baltic Sea and deep within the granite roots of the Alps, two massive mechanical beasts are currently chewing through the earth, performing a feat of engineering so radical, it sounds like science fiction. We are talking about the Fehmarn Belt Fixed Link and the Brenner Base Tunnel. These aren't just your average highway tunnels. These are multi-billion-dollar subterranean arteries designed to fundamentally reshape the map of Europe. Imagine traveling from Germany to Denmark in 7 minutes or blasting through the highest mountain range in Europe on a high-speed train that never has to climb a single slope. For decades, the geography of Europe has been a barrier to trade and travel, forcing trucks into long detours and trains into slow, grinding climbs. But right now, at this very moment, thousands of engineers are working in high-pressure environments to erase those barriers forever. Today, we are going deep underground to explore the high-stakes technology, the massive risks and the sheer human willpower driving the two megaprojects that will change the European continent for the next century. Let's start with the one that is literally being built on the sea floor, the Fehmarn Belt Fixed Link. If you look at a map of Northern Europe, there is a frustrating 18-kilometer gap of water between the German island of Fehmarn and the Danish island of Lolland. Currently, if you want to cross, you have to wait for a ferry, which takes about 45 minutes, not counting the boarding time. If you're a freight train, the situation is even worse. You often have to take a massive detour of 160 kilometers. The solution? Building the world's longest immersed tunnel. Now, most tunnels are bored using a giant machine that eats through rock, but the Fehmarn Belt is different. Engineers are prefabricating 89 massive concrete sections on land. These segments are gargantuan, each one over 200 meters long and weighing 73,000 tons. To put that into perspective, each segment is about the weight of 14,000 elephants. The process of moving these concrete titans is an orchestral maneuver of physics and precision. In a massive purpose-built factory in Denmark, the largest of its kind in the world, these segments are cast in high-performance concrete. Once they are cured, the ends are sealed with temporary bulkheads, and the segments are actually floated out into the Baltic Sea. Using high-precision GPS and powerful tugboats, the team positions them over a pre-dredged trench on the sea floor. Then they slowly flood specialized tanks to sink the segment with millimeter accuracy. Once it's down, a specialized locking system pulls it tight against the previous segment, creating a waterproof seal. The sheer scale of this Lego-style construction at the bottom of the ocean is unprecedented. By 2029, this tunnel will house a 4-lane motorway and 2 electrified rail tracks, cutting the travel time from 45 minutes on a ferry to just 7 minutes by car and 7 minutes by train. But as impressive as the Fehmarn Belt is, there is another giant project happening thousands of miles south that is tackling an even more formidable opponent: the Alps. The Brenner Pass has been the primary trade route between northern and southern Europe since the Roman Empire. But the mountains are brutal. Modern heavy trucks and trains have to struggle up steep inclines, consuming massive amounts of energy and creating a bottleneck for the entire European economy. Enter the Brenner Base Tunnel, or BBT. This is a 64-kilometer rail tunnel that will connect Innsbruck in Austria to Fortezza in Italy. When completed, it will be the longest underground rail link in the world, surpassing the Gotthard Base Tunnel in Switzerland. The engineering philosophy here is flat rail. By drilling through the very base of the mountains, engineers are creating a track that has almost zero gradient. This means a heavy freight train that currently needs 3 locomotives to pull its load over the pass will be able to do it with just 1, traveling at high speeds. It's a total revolution for the logistics of the continent. But to get there, they have to drill through some of the most complex geology on the planet. The Alps are a mess of different rock types, fault lines, and underground water reservoirs. To handle this, they are using tunnel boring machines, or TBMs, which are essentially subterranean factories. These machines are over 200 meters long and feature a massive rotating cutter head that can grind through granite like a hot knife through butter. One of the most fascinating aspects of the BBT is how they manage the waste. Excavating a 64-kilometer tunnel produces millions of tons of rock spoil. Instead of just dumping it in a hole somewhere, the project has turned into a massive recycling operation. Much of the excavated rock is crushed, processed, and turned back into concrete right there on site to line the very tunnel it was taken from. This circular economy approach is essential for a project of this scale, both for environmental reasons and for cost saving. The tunnel also features an exploratory tunnel located 12 meters below the main tubes. This isn't just for research, it serves as a drainage system for the massive amounts of groundwater they encounter, and will eventually act as a service and emergency tunnel. The technology inside these tunnels is just as important as the concrete and rock. In the Fehmarn Belt, the ventilation system has to be powerful enough to clear out exhaust fumes from a constant stream of cars over an 18-kilometer stretch, while also ensuring that in the event of a fire, the smoke is diverted away from passengers. They are using massive longitudinal fans that can move thousands of cubic meters of air per second. For the Brenner Base Tunnel, the challenge is different. Since it's a pure rail tunnel, they have to manage the piston effect, the massive pressure wave created by a high-speed train entering a narrow tube. To solve this, the two main tunnels are connected every 330 meters by cross passages that allow the air pressure to equalize between the tubes. Safety in a megatunnel is a top priority, and the 2026 updates for both projects show some incredible innovations. The BBT has 3 massive emergency stations, located deep inside the mountain. These are essentially underground bunkers with their own ventilation and water supplies, large enough for hundreds of people to evacuate into. There are specialized safety tubes on either side of the road and rail decks, and a full-time maintenance crew located in a specialized facility right in the middle of the tunnel under the sea. These projects are designed to be some of the safest places on the continent, utilizing AI-driven sensors that can detect a single stalled vehicle or a rise in temperature of just a few degrees in milliseconds. The economic impact of these two projects is hard to overstate. The Fehmarn Belt Link is the final piece of the ScanMed corridor, a transport spine that stretches from Scandinavia all the way to the Mediterranean. By removing the ferry bottleneck, Denmark and Sweden will be much more integrated into the European mainland. Copenhagen and Hamburg will essentially become part of the same regional economy. In the south, the Brenner Base Tunnel will allow for a massive shift of freight from road to rail. Currently, over 2 million trucks cross the Brenner Pass every year, causing significant noise and air pollution in the fragile alpine valleys. The BBT is designed to handle over 300 trains per day, moving the equivalent of thousands of truckloads onto clean, electrified rail. But megaprojects like these aren't without their sobering challenges. The environmentalists in Germany and Denmark have raised concerns about the impact of dredging on the marine life of the Baltic Sea. In response, the Fehmarn Belt project has implemented one of the most comprehensive environmental monitoring programs in history. They have underwater microphones to monitor for porpoises and specialized systems to ensure that the sediment from dredging doesn't smother the seagrass. This balance between massive infrastructure and ecological preservation is the new standard for 21st century engineering. We aren't just building over nature anymore. We're trying to build asterisk with asterisk. The workforce behind these tunnels is a truly international effort. At the BBT site, you'll find engineers from Austria, Italy, Germany, and beyond, working in shifts 24 hours a day. The conditions inside a TBM can be intense. Despite the advanced cooling systems, the ambient temperature deep inside the mountain can reach 40 degrees Celsius due to the heat of the rock and the friction of the machine. The workers have to be highly trained for hyperbaric conditions, as some parts of the work require them to enter pressurized zones to maintain the cutter heads. It is a world of high-tech machinery and grimy, hard physical labor combined into one. Let's talk about the boring part of boring a tunnel. It sounds repetitive, but it's actually a high-stakes chess match. The TBM operators use high-resolution sensors to see into the rock several meters ahead of the machine. If they hit a pocket of soft clay or a high-pressure water vein unexpectedly, it could flood the machine and halt the project for months. In 2026, we are seeing the use of acoustic tomography, where sonic waves are bounced off the rock to create a 3D map of what lies ahead. This allows the operators to inject specialized grouting into the rock to stabilize it before the cutter head even touches it. It's like having X-ray vision through a mountain. The Fehmarn Belt project has its own version of X-ray vision. Because they are placing segments on the sea floor, they have to deal with the visibility issues of the Baltic Sea. They use a combination of sonar and high-precision ROVs, remotely operated vehicles, to guide the 73,000-ton segments into place. The tolerances are tiny. We're talking about a gap of just a few centimeters over a 200-meter-long concrete block. If a segment is misaligned, the waterproof seal won't hold, and 80 kilometers of tunnel could be compromised. The precision is more akin to docking a spacecraft with the International Space Station than it is to traditional road construction. The scale of the logistics hubs created for these projects is a mega-project in itself. For the Belt, they had to build a brand new port in Redefine, Denmark, just to handle the materials and the floating of the segments. This port will eventually be turned into a massive recreational area and nature park once the project is finished in 2029. This idea of legacy infrastructure, where the construction sites themselves become valuable to the community, is a hallmark of these modern European projects. They isn't just building a hole in the ground, they're building a new landscape. As the Brenner Base Tunnel moves toward its completion date in the early 2030s, the finishing phase is already beginning in some sections. This involves the installation of miles of copper cables, specialized rail tracks that are designed to minimize vibration, and the massive transformers needed to power high-speed trains. The sheer amount of electricity required to run a 64-kilometer tunnel, not just for the trains, but for the lighting, ventilation, and safety systems, is equivalent to the power needs of a medium-sized city. To offset this, the project managers in Austria and Italy are looking at integrating hydroelectric power stations directly into the tunnel's drainage system, using the water that naturally flows out of the mountain to generate clean energy. The complexity of the Brenner project also comes from the fact that it has to connect seamlessly with the existing rail networks of two different countries. This means integrating different signaling systems, different electrical voltages, and different safety protocols. The digital twin of the tunnel, a complete, real-time 3D model, is being used by both Austrian and Italian rail authorities to practice emergency drills and optimize train schedules years before the first passenger ever steps on board. This level of international interoperability is what makes the BBT a truly European project, rather than just a local one. One of the most impressive feats in the Fehmarn Belt is the special segment design. Out of the 89 sections, 10 are special segments that feature a lower floor for maintenance vehicles and specialized gear. These act like the organs of the tunnel, housing the pumping stations and the power substations. By integrating these into the tunnel structure itself, they save space and ensure that maintenance can be performed without ever having to close the motorway or the rail line. This modular thinking is changing how we look at infrastructure longevity. These tunnels are designed to last for at least 120 years with minimal major repairs. We have to mention the cost of these megaprojects. The Fehmarn Belt is costing around 7 billion euros, and the BBT is approaching 10 billion euros. These are taxpayer-funded investments in the future of the continent. While the price tag is sobering, the studies show that the economic return over the lifetime of the tunnels will be several times the initial investment. By speeding up trade, reducing carbon emissions, and creating a more integrated Europe, these tunnels are basically time machines that give us more hours in the day and a more vibrant economy. The psychological impact of these projects on the regions they connect is also profound. For the people living in the Alpine valleys, the BBT represents a rinfrescanti change, a future where the constant noise and smog of millions of trucks are gone, replaced by the silent hum of trains deep underground. The Fehmarn Belt represents a new era of connectivity, where the sea is no longer a barrier but a gateway. These are social engineering projects just as much as they are civil engineering ones. As we look at the progress in 2026, the BBT is over 80% excavated. The breakthrough moments, where the machines from the Austrian side meet the ones from the Italian side, are planned for the next couple of years. These are moments of extreme celebration for the teams involved. It's the second, where years of planning and drilling finally result in a light at the end of the tunnel. Several kilometers of segments are already in place on the sea floor, and the dredging is almost complete. The projects are moving from the exploration phase to the fitting out phase, which is when the real transformation begins. The role of AI and machine learning in these 2026 updates cannot be overlooked. For the BBT, AI is being used to analyze the vibration patterns of the TBMs. By listening to the machine, the software can predict when a cutter tool is about to wear out or if the rock density is changing. This predictive maintenance keeps the machines running longer and prevents catastrophic failures deep underground. In the Fehmarn Belt, AI helps manage the dredging plume, using real-time sensors to adjust the speed of the dredging to ensure that the water turbidity stays within safe limits for the local ecosystem. This is intelligent engineering. Think about the aerodynamics of a 64-kilometer tunnel. When a train travels at 250 kilometers per hour, it pushes a wall of air in front of it. In a normal tunnel, this creates a loud sonic boom when the train exits. To prevent this, the portals of the BBT are designed with specialized vents and flared openings that gradually dissipate the pressure. It's the same type of technology used for high-speed trains in Japan, but on a much larger scale. This ensures that the neighbors living near the tunnel entrances aren't disturbed by the pressure waves. The Fehmarnbelt fixed link also has a resilience plan for the future. With sea levels rising due to climate change, the entrances of the tunnel are built on massive artificial islands that are raised several meters above the current high tide mark. The gates themselves are designed to be storm-proof, capable of withstanding the most extreme Baltic surges. The engineers aren't just building for the world we have today. They're building for the world we'll have in 2100. This future-proofing is a core part of why these megaprojects are so expensive. They are designed to be the last tunnels standing. The Brenner-based tunnel also serves as a massive project for hydrology. Because it's so deep, it essentially acts as a giant straw, pulling water from the surrounding rock. This water has to be managed, treated, and released back into the rivers at the correct temperature so it doesn't harm the fish. The cooling systems are so advanced that they actually recover the heat from the tunnel air and use it to provide district heating for the nearby towns. It's an incredible example of how a transport project can become a renewable energy project. The synergy between these two tunnels is what will really change Europe forever. They remove the northern and southern hard borders of the continent's central corridor. You can imagine a freight container being loaded in Oslo, Norway, traveling through Sweden, crossing the Fehmarnbelt into Germany, and then blasting through the Brenner-based tunnel into Italy, all without ever leaving a train and without ever being delayed by a ferry or a mountain storm. This is the physical manifestation of the European Union. A seamless, efficient, and vibrant network. The human factor in these tunnels is the most terrifying and incredible part. Imagine the courage it takes to work on the sea floor or under 2,000 meters of rock. The engineers use mixed reality headsets to overlay the 3D blueprints onto the actual rock face, allowing them to see where the support bolts need to go with perfect accuracy. This merger of digital and physical worlds is what allows us to push the boundaries of what is possible. Behind every kilometer of tunnel is a story of a human being solving a problem that has never been solved before. As the Fehmarnbelt segments continue to be sunk one by one through 2026, the trench on the seafloor is being covered with several layers of protective rock. This isn't just to keep the tunnel in place, it's to protect it from ship anchors and sinking vessels. Even if a massive container ship were to sink directly on top of the tunnel, the structure is designed to remain intact. This armor is what makes an immersed tunnel arguably safer than a bridge, which is exposed to wind, ice, and ship collisions. The Brenner-based tunnel is also a feat of acoustics, to ensure that the flat rail doesn't create a resonance that could damage the mountain's stability. The tracks are laid on a multi-layered damping system. This involves heavy concrete blocks, sitting on high-performance rubber bearings. When the train passes, the vibrations are absorbed by the track bed before they ever reach the tunnel walls. For the passengers, it will be the smoothest and quietest train ride of their lives. For the mountain, it will be as if the train isn't even there. As we look toward the 2029 opening of the Fehmarnbelt and the 2032 opening of the BBT, we have to appreciate the patience required for megaprojects. These projects take decades from the first feasibility study to the first train. They require the cooperation of multiple governments, hundreds of companies, and the support of millions of citizens. They are a testament to the fact that we can still think long-term in a world that is obsessed with the short-term. They are monuments to the future. The vibrant energy of these tunnels will be felt for generations. They will reduce the carbon footprint of the continent by millions of tons of CO2 every year. They will save lives by moving dangerous truck traffic off the narrow mountain roads and onto safe, automated rail lines. They will create a seamless Europe that is more resilient to the challenges of the 21st century. The Fehmarnbelt and the Brenner are the heart and the lungs of a new European transport system. So when you think about the future of Europe, don't just look at the cities or the space programs. Look deep. Look at the massive machines chewing through the Alps and the concrete titans sinking into the Baltic Sea. The map is being rewritten, and the barriers are being broken. We are witnessing the birth of a new continent, one that is connected by the sheer power of human ingenuity and the megaprojects that make it all possible. The megatunnels are coming, and with them a change that will be felt by every traveler, Every business and every citizen in Europe. The wait for the ferry is almost over. The climb over the mountain is almost done. The subterranean future is bright, and it's being built right now, under our feet. Stay curious about the world's megaprojects, because they are the blueprints of the world our children will inherit. The total transformation of Europe is underway, and it's happening 1 meter at a time, deep in the dark. Breakthrough is just around the corner, and the light is getting brighter. These 2 tunnels are the victory of the planers over the procrastinators. They are the proof that we can still do big things. Europe is growing, and it's doing it by going underground. Thank you for joining us on this deep dive into the 2 tunnels that will change Europe forever. The future is fast, it's flat, and it's submerged. See you on the other side.